Hey everyone, welcome back to Fusioneers. I'm Joseph, and today we're going to do another expert design walkthrough. Today we have Luis with TwoThingies. He also has some other Instagram pages where he shares different content. I'm pretty excited about what we'll be going through with today. Here's some of his designs that he's done in the past. This is his Thangs.designs account where he makes some desk accessories. And then he also has Luis Works where he shares some more kind of engineering and coding based information as well. And here's some of his designs. I think that they're very aesthetically pleasing, and you can see that he has a really nice photography as well. So Luis, you're telling me a little bit before we started recording how you and your fiance kind of manage this account. Can you tell the audience a little bit about how y'all do that? I think it's pretty interesting that y'all can do two person Instagram account, and it works out pretty well for you.
Yeah, thank you. My fiance Uri, she's an architect. She has a good eye for aesthetics, and she's really good with photography. And I'm more, let's say, on the modeling side. Like I like designing functional things, using 3D printing to make functional designs. So we decided to combine those two sides, let's say, to share useful designs for 3D printing.
Yeah, that's awesome. I mean, I really like I think that one of the first things that I saw from your account on Instagram, the algorithm was working pretty well here. I saw this dual diameter camera lens and thought that was a really useful design, for photographers especially. I feel like anytime you change out your lens, you have the caps hanging around that you don't really know where to put them sometimes. So I think this is a really useful thing. And then also I think this is a really nice design. I've done some cable management type things myself, and I think I can really appreciate how you can have the main product being the headphones, and also manage the cables with that. So I think that's really well done. And then here's some other designs that I pulled from your page. Also really like how y'all have you and your fiance have integrated. This is corkboard, is that right?
Yes. It's a thin corkboard. We like to use it as padding. We like to add some non-printed materials to 3D prints, like to improve the functionality and to give like more premium feeling to some designs.
Yeah. I think that's also some of the I do some enclosure kits, and I think that it's a really nice way of kind of supplementing the things you can do with 3D printing with other materials. Like here you have chopsticks, which is pretty interesting as well, and I like kind of just the overall theme of this design. And also I think that this goes well together. I like the contrast with the corkboard and the black there. So also like this texture that y'all added. I think that really kind of complements the design well. And then here's some more from his Things.designs account, where I think it's more focused on desktop accessories. And here you see the corkboard again, and this is looks like a marker organizer. So also using some corkboard. So I think I just really like that aesthetic. I think that's a really clean design language that you have there. And if you want to see some more stuff from TwoThingies, they have a cults page where they have different files. Some of them are free and some of them are paid, but they're all very high quality, as you can see, that the ones we've went through. And then if you want to follow TwoThingies on Instagram, this is the QR code, so you can go ahead and scan that and follow them. And now I'm going to hand it over to Luis, and we're going to go through a fusion design. So we'll get started with that.
So here's what we will be doing today. This is a holder for an Apple AirTag. So you see here, it's a very simple design. Has a case and a lid. Lid can be placed using some SnapFit hooks. So I'm going to be showing you how I modeled this. It's a pretty easy design, so I think it's great for when you're learning Fusion, or when you try to design something simple to 3D print. This could be a great example. So
Yeah, I like how, to sort of interrupt you there, but I like too
yeah,
how you have the AirTag as a link component. That's for people that aren't aware. You can basically insert other components into your design to basically it references another design in a way, so you can have the link component outside of your file and then kind of insert it and then design around that. So if you're designing multiple AirTag holders, it makes sense to make the AirTag once, and then you can pull that in and model around that your different designs for it. So I think that's a really good use of that feature within Fusion. So
yeah,
sorry to butt in, but I just like to
no,
kind of make a comment where I think that you did a great job using Fusion there. So go ahead.
thank you. Yeah, thank you. Yeah, that's actually the first step. Well, now the first step is always save your work before
Yeah.
anything goes wrong. You can always come back to it. So yeah, let's get started. So the first step, of course, is to insert a new component. In this case, I have already saved here. Have a folder with 8 different AirTag designs. These all are, not all of them, some of them are already online. And here's the, let's say, the main component I use to design all other cases, is this AirTag. You can find AirTag models free to download online anywhere. This one, I modeled it myself. For people who don't know, maybe this is an interesting thing. Apple releases some design guidelines which are very specific, and you have the drawings for all the components or the accessories when you want to design an Apple accessory. So, for example, this is an AirTag. I just downloaded the Apple design guidelines, and they have the profile of the AirTag. You see, they have also all the contour points. So I just copied that to Fusion, and this is a revolve body. So the only feature, if I open it, I cannot edit in place with the free version, but when I come here, you see it's just revolve operation. I separated the cap and the body, but it's not necessary if you just need the contour. So
for people that are wondering, one of the reasons, if I may interject here, is the reason he separated it, most likely, I'm just assuming this, but that way you can assign different material or different appearances to both of the bodies. So it makes it easier to make it look more representative of the actual product. So as you can see, it has kind of a mirror finish on the bottom there, and then the more white plastic, which is characteristic of a real AirTag. So is that what you were thinking when you did the two bodies?
Yeah, on the on one hand, yes. On the other side, I wanted to see if it was possible to separate the two of them for some designs. Not in this one. In this one, we are going to do now. But there are some designs in which I wanted to be able to split this and pull it out. So having separate bodies is good for that. It's easier to do for doing
that. Makes sense. And then just real quickly, I didn't know that Apple released those. I've always just tried to reverse engineer it by hand. Where do you go to find those? Is it just, do you search something, or what's the best way that you know of? Hey everybody, so during the recording we couldn't find the correct URL, but after the fact Luis was able to find it and send it over to me, and this is the PDF that he was talking about. For instance, here is the recommended dimensions for the MagSafe magnet on the back of the iPhone. So I think it could be super useful if you're making some Apple accessories and things like that. So I'd encourage you to check it out. It's over 500 pages, so a lot of information in there about making things to the recommended dimensions. So we'll have that down in the description if you're interested in it. And now we'll go back to Luis and continue the design.
So we can link this in the video description, like for people to download if they want to use it. This
awesome.
AirTag design.
Well,
so
thank you.
Yeah, sure, no problem. Anyways, yeah, this is free information online. Like anyone can do it. So it's just for people who are curious to see it. Okay.
All right.
Right. So coming back here, so the first thing I did was yeah, insert this directly into the design so I can reference it while designing. So the next thing let me show you how it works physically. So the idea of this design is to, I don't know if it's something we can see. So the idea of this AirTag holder is to have the logo visible here, and then the rest of the AirTag is covered. So I'm going to create an offset plane and start drawing at this level. So when the cap meets, before the cap meets the rest of the body. Okay, so first thing here, I'm going to create an offset. Instead of distance, I will select two objects. And then I will select here this edge, the bottom edge of the chamfer, or a point on that edge. For example, here. And make it parallel to this plane here. And then selecting this point, it becomes coincident with that. That way I avoid taking odd measurements, like this is 0.88 millimeters or something like that. I avoid taking this measurement by hand. I just reference some geometry to do that. And yeah, so I like to call this sketch, I will create a sketch here. I will call this one top plane. I like to give them names to the planes, so it makes it easier for me to reference it back.
So basically, you made a new plane that's going to be the base, or the part that you extrude from, essentially, for people who aren't, because the AirTag is a little curved on that surface there. So you essentially offset the plane to where it's at the level that he wants it to be, flush with the edge there. So just for everyone that's listening.
Yeah, exactly. For example, well, there is a planar face here. You could sketch here, but I prefer to avoid taking like this odd measurement. Like, for example, here is 1.41 millimeters. Then you have to remember that, make an offset of that distance. Then everything you extrude has to consider the offset from this face. So I just prefer to place the sketch plane on a reference geometry in this case.
Making it easy for yourself.
yeah, exactly. So the next thing I do, I create a sketch here.
And did you, for that window, did you use the S shortcut, or is that?
Yes. Yeah, okay. I pressed S on the keyboard. You don't usually have it. Like when you press S on the keyboard, you get some options, right? I think this sketch, the create sketch option wasn't here by default. I added it like when you search for any command, like for example, if I look for a shell command, it gives you the option here to add it.
Like pinning it, sort of. Okay.
Yeah. So it becomes available next time.
See. Yeah, for some reason, I've never gotten a good habit of using that. It's a very useful thing to use. So just the S key will let you search for different commands, so make you more efficient.
Yeah, it helps you save some time. Also, sometimes you don't remember exactly where some command was, so it's easier to just have it there, especially things you use all the time. So here what I do is I do a projection of the AirTag to model from it. So I do project on Sketch. I press P here on the keyboard, and that brings you the window for the project command. So I will project some geometry, some yeah, I will project some specified entities in this case. So I would select here the outer edge of the AirTag and project that one. And I actually also want to project the entire body, the outer contour of the AirTag. Okay, so now I have those two features. I can hide the AirTag, and I can work on this. So I like also to create some parameters to adjust later on the design. Things that I know when, especially with 3D printing, things that I know I will probably need to come back and change after maybe a first prototype. So I come here on the solid workspace, on the solid tab, and I select here the change parameters, and I create a new one. So first one is definitely a clearance parameter. Of course, in this case, I already did the design, so I know the actual value. So
Yeah.
I'm not going to change it, but it's useful to have it. And I define some other things, like, for example, a wall thickness that I can use while I'm designing. And I think that's it for now. Maybe I can add some others downstream, like as we go. So coming back to the sketch, I create a rectangle, press R, brings the rectangle here, and I select the center rectangle and create a new one, just like that. And I just add some tangent constraints to make it tangent this one. Oh no, sorry, I messed up. Okay.
That's all right.
Okay, so first thing I want to do now is to specify to create some offset lines from these two, so we don't have any matching surfaces, any matching faces to the AirTag, just with a small clearance, the parameter that we created. So I create here an offset, and I select, for example, this one here, and I give it the value of the clearance parameter that I just created. In this case, I make sure that it's on the outer side. If I wanted to change that, I could just click here. So here's OK. And I will do that also for this one, also referencing the clearance parameter.
What makes that so nice is that if you have a printer that's slightly different tolerance, it's easy to change your clearances there just by changing the parameter, and then everything updates, and you can easily, print again, or even if you have a small part, you can try a couple of different clearances on one print bed just to be a little more efficient to figure out which one fits best for your printer. So I like that a lot.
Yeah, it's really, really useful. Like the times I didn't create the clearance as a parameter, it takes more time to go back in the design and check where did you use this dimension, where is it propagating, what is it, what features are affected by it. So it's just easier to just have a parameter that you can change directly.
Right.
So yeah, once we have that, I press R, or I come here. It's the same, and I select a center rectangle. I center it here, and I just throw it in there. I don't care about the dimensions. That's why I have the reference geometry. So I add some tangent constraints to the outer circle. So now it's tangent there, and also here. Fine. So that defines like where the AirTag will be enclosed, like the inner side of this enclosure. And I want to create the outer side. So I just add another offset, and I just add the wall thickness. Oops. I just add the wall thickness. In this case, I just want it on the opposite side. So yeah, now we have this base sketch. I can directly from here hit E for extrusion. Maybe I'll bring back the AirTag just to see what I'm doing. So what I do is select all the profiles. Select all the profiles, and I'm going to extrude it. Now I know this because I already did it. Distance I want to use is 9 millimeters, minus 90 millimeters, and I'm making sure it's in this direction, of course, to cover the AirTag. That's why it's helpful to have the other body visible. Since it is a different component, it won't merge, so it by default it creates a new body. If I was using the AirTag as a body within this same component, then I will need to make sure it's a new body, otherwise it will join everything together. So yeah, I just create this one. Next, I want to add some fillets to this. So I pressed F on the keyboard, and I can select here the edges. Now I'll give it a 6 millimeter radius.
And for your fillets, do you have any? Do you kind of just? I mean, I kind of just guess and check honestly, and just see what looks good. Do you have any kind of thought process behind that, or just kind of what's pleasing to the eye? There's probably some design science behind it, but I usually just kind of pick the one that looks best to me.
Yeah, well, really with this kind of designs, they are functional, but mostly aesthetics. Like they won't break, like they don't have to hold any weight or something like that. So it's just the form factor that you want to get.
Right.
So what I do is, for example, if I have different designs in the same series of designs, like if I want to make different designs that look similar together. For example, the desk accessories series that you were showing on the other Instagram account, I try to keep the same ratio of radius versus the side of the component. Like, for example, if I will make designs, for example, this one is 35 millimeters and the radius is 6 millimeters. The ratio between those two numbers, I will try to keep it constant. So if I design another component which is part of this series, let's say a bigger component, I don't know, maybe a base, a holder for a phone holder, or an iPhone charger or something like that, I will keep the same ratio of radius versus side to make it look let's say similar. Okay,
I see.
Yeah, and other thing is, if it was a component that is more structural, like something that needs to bear some loads, then I will check. For example, if it's something I need to bend. For example, if I need to bend some sheet metal component or something around this radius, then I will check the thickness. You know, they always tell you 1.5 or 2 times the thickness should be the radius.
That's it.
But for more things like that, it's just depending on what shape you want to get. I don't have a rule.
Yeah, that makes sense. I like the ratio thing. I never really thought about that, but yeah, that makes a lot of sense.
Yeah. So here the next thing I do is I do a shell. We'll create a shell here on the top face. In here I specify again the wall thickness, making sure it's an inner shell. Okay. So I hit OK. So what I also like to do is to create a cross section. I'll make a section analysis here so we can see what's going on. So we have a weird shape with this opening here, and then it intersects the AirTag. So I'll just delete it. I can just press delete here. Oh, it didn't work in this case. If I just press these two, I can delete this face. Okay, so it disappeared. So if I hide the AirTag, we have this empty space here, this cavity here, but there's an intersection here. There are intersecting bodies here. So what I will do is I will pull up this face even more, 2 millimeters. So that made the intersection even worse. But now what I do is I create a cavity where the AirTag can sit in this print. So I will just do a combine operation. I look for the combine operation here. And I use this cavity as a target body and the AirTag as a tool. And I make sure I'm selecting the cut operation. That way I remove the intersection. And when I remove the AirTag, if I hide it, you have this nice space where the AirTag can sit when you insert it. So we can move on with the upper side, with the upper part. Now, if I look at it from the sides, yeah, it covers the AirTag, so it's fine.
Yeah, I like how, so when you subtract out the body there, it helps when you have to make sure that the body is right, that you're subtracting out, and make sure it fits good. But it really does make a pretty tight fit there, and that's an easy way to make things. As long as you reverse engineer the original body, it'll fit pretty well. As long as the printer also is pretty holds pretty good tolerances. So yeah, I like that technique.
Yeah, thanks. Yeah, it's really useful, and it's one of the main things why I wanted to design this following the let's say the exact dimensions. So yeah, now we will make a new sketch on the top face here. This time I went to the menu to select the sketch option. I'll do some other offset faces here, offset lines here. Again, using the clearance. That's why it comes very useful, because you can use it several times. In this case, I want this to be on the opposite side. And I will also make some line. I pressed L on the keyboard, and I place it here on the center and come all the way up here. Just to do it again, so you can see I place it here, and then when it comes here, it's just at the center. It gives you this midpoint symbol, this triangle, this little blue triangle there. I like to make this one a construction line. And then I will make a hole here for this keychain, and I will give it a diameter. But I also like to create a parameter for the hole diameter, because it's something you could need to change. Hole diameter. I'll give it 3.5 millimeters. So when I come back here, I can just it's the hole diameter, and then I'll add some distance here across this line to constrain it. So I press D for dimension. I select this point, click on the circle. I right click on it, and I select the pick circle or arc tangent. So that way, now it doesn't do it. press D again, escape, escape, and D. Okay, so I can
There you
add the
go.
dimension, yeah, instead of using the center of the circle.
Yeah, I just learned that. I think Autodesk or one of the Instagram accounts did a short about that, and I learned that little trick recently. It's pretty useful in a lot of different situations. So yeah, glad that you showed that, because it's something that if you don't know it's there, it can be, you have to do some kind of mental math and tricks in your head to get it in the position you want to, especially circles or slots. So yeah, I like that little tip.
Yeah, it's really useful. Yeah, if you don't know it exists, then you start doing math like, okay, this is the diameter, this is the distance I want. I want to subtract half the diameter. So yeah, it's just much easier, very convenient. Yeah, so the next step is I'll just create another circle. I want to make it coincident with this one, and I'll make it 6 millimeters. Actually, let me show you why I do 6 millimeters. Maybe I can do it a different way. Instead of the circle, I would just use another offset. I want the offset to be slightly less than my wall thickness. So my wall thickness is 1.6 millimeters. If I do that times 0.8, that gives me around 6, so 6.06. So it's just a slightly thinner wall on this area here. What I did before, I just rounded that up to 6 millimeters. So I just want to make this corner like where the keychain is going to be attached. So it will be part of the frame, and then the lid will have this cutout here. So you will have this lid and the frame with this corner here. I think it looks pretty good. I mean, I like the way it looks.
So for what was the reasoning behind making that wall thinner? Was it just a design preference, or was it interference thing, or what was your thought process behind that?
Well, it's just because I don't want to. If it was thicker, for example, if we added this, well, we could just leave it as 1, for example. But it just takes up a little bit more space here.
I see. Yeah.
It's a slight undercut. It's let's say, what do you call TOC? Obsessive.
Oh yeah,
no,
OCD.
OCD. Yeah, sorry,
Yeah,
that's
yeah.
my description. So, so yeah, but yeah, really, it's not that important actually.
I see. Yeah, I was just
yeah.
curious. Cool.
It's just preference, personal preference. So now I'll just extrude the lid. So yeah, it's just this area here. I will make it 2 millimeters, this opposite direction. Since it's not touching anything, it's just a new body. Otherwise, I will again need to make sure it's not joining.
Yeah, that's important for people that are just getting started. It's really easy to not notice that and then have parts get joined together, and then you kind of get lost in where that happens. So yeah, I'm glad you're pointing that out.
Yeah. When I started with Fusion, I come from SolidWorks background. Like I used a lot of SolidWorks in college and university, and I also worked a little bit with it on my early days when I just graduated. When I started using Fusion, I found that it defaults to join all the time when you have separate bodies. So it's good to keep an eye on that.
Right.
You
For
get used
sure.
to it after some time.
Definitely.
So yeah, this sketch here, I will use it now again to extrude the other part of the frame, missing part here. So I'll just select the missing profiles. One important thing, when I created this, let me go back there so it's easier to see. So when I created this line here, I made sure it went all the way through the outer line. So I get this small, let's say, section here. Because then when I extrude the frame, this would be part of the frame. I don't want this if I didn't have this small line here, I will just be able to select this one and this will be open. So I just wanted to make sure it connects to the rest of the frame. So if I just hide the lid now, I hide it to make sure I just get I can join directly just the frame. I will extrude it to this bottom face and hit OK. Now it's joining this this whole body. Okay, so we have these two bodies together. Now I like to add some naming here, so it's easier to distinguish. Also,
For people
when you
that are, yeah, sorry to interrupt, but for people that are getting started with Fusion, when you change the name of the body and you export to 3D print, it defaults to whatever you have the body named as the STL file. So that's sometimes you'll see that if you don't change the body name, it'll be body 1, body 2, and then it's sometimes difficult to remember what's what. So if you wanted to export with a certain name, then you just need to change the body name, like you just did. So
yeah, exactly. That's another reason. Like when you export, you find then body 1, body 2, body 3, and it's like a mess. Also, when you're modeling, sometimes if you want to reference some body within your components, you need to start toggling between them to remember, okay, which one is which. So just having the name really helps. And also, like I like to add some appearance to the bodies, just to yeah, make them easier to distinguish. So for example,
I've thought about changing my default color to something besides the gray metal at some point, just so it'll be different.
Yeah, I mean, it's also just nice to see it, to see in colors, you know.
Right. Yeah.
See what you're working on, well, what it would look like. It's not a render, like a photorealistic render, but it gives you an idea of what it looks like.
Yep.
Yeah, so we are almost there. There are a couple of things still to check. Like, for example, if we look at it from the section analysis, you see there's a little bit of interference here, not much, but still some interference. And then if I create another section analysis example, I can show you from here, for example. Let's see. Yeah, there you can see there's that undercut where I extruded. So I just do some combine operations. I just do some more combine operations here. For example, here's the target body. Again, the AirTag is the tool. I need to select the body of the cap in this case, not the. Oh no, it's the actually it's the body. And then I do the same again for combine. You could just do the combine operation at the end, so you don't have to repeat it. Like we did a combine operation here. Something we could do is, again, it's like pull this back here. So it's now further down in the history line, and I can edit. Actually, I don't need to change anything because I already had those two bodies selected. But the change is, since it's now after the extrusion of this part, you see it now cuts the small interference we had there.
Yeah, makes
see?
sense. Mm-hmm.
That way you don't need to make a separate combined operation.
All right.
Yeah, so now we need to just extend this hole. I can just do that. You could do to all or to the side, to the bottom side here. I just do long distance that I know it works, or just the all option. Now we have the hole opening there. And yeah, we have a lid and a case. Something I added here on this holder to make it easier to install the, I don't know if you can see on the camera. So something I added here is a chamfer on the corner.
Oh, yeah.
Otherwise, yeah. So to make it easier to install to insert the keychain. So you have this ring here. It's not big enough to hold, you know, the whole thickness of the AirTag. So
you can get a smaller diameter ring essentially to fit around it.
Yeah. Otherwise, you will need like a really huge one to fit all this 9mm thickness. Yeah. To be able to do that, I create a midplane here. So I select.
Oh yeah, this is gonna be this is a good trick that I didn't know about for a while.
Yeah. Yeah, making angled plane just using the midplane trick. Yeah, so, and then I can sketch here.
All right. So what he essentially did was it made a 45-degree midplane between two 90-degree faces. So I always thought about midplanes as essentially making like a line of symmetry between two flat planes, but it also works as basically splitting an angle in half. So that's a really easy way to get like a 45-degree plane for you to sketch on. So yeah, I like that tip a lot.
Yeah, it's pretty useful, really useful. Also, when you have all the angles, even if it wasn't a 90-degree angle, like if you had, I don't know, a 57.5 corner here, and you just want the midplane there, it still works, still gives you the middle, even if they are not parallel faces. Right. So it's really, really good. So here I just create another sketch. I do a projection again, in this case, of the case geometry. And I also want to select, I will do another projection. I will select by entities, and I will select this face here, just to see where it's located. So I will do some angled line here. I will make it 45 degrees. And then I give it some distance from the top. Here, I think I used 2.5 millimeters. I'm not sure. In any case, then we can change that. Maybe I could add some parameter, like corner thickness. Make it 2.5. I need to change that afterwards. So there's that. And I can extrude it. I do symmetric. I give it a whole length, or you could just do all. If you don't mind, like in this case, we don't have any other components on the side, so we could just do all, and we cut it. So there we have this slim corner where you can insert a smaller hole. smaller ring.
Yeah, it looks really good.
Yeah, thanks. Yeah, I think I also like the aesthetics of it. Like it looks sleek. I think I like the way it looks. So yeah, now we have the lead and the case, but they are floating in the air. So I will start adding the SnapFit tabs. So this is something I learned from Clock Sprint 3D a long time ago. He made a YouTube video. I don't know if you're familiar with him, with his work. He creates different enclosures and boxes and fun designs for 3D printing. And he did some YouTube videos showing his workflow for creating SnapFits and modeling 3D printable components. And since then, I've used it all the time. It's a way to create SnapFits. I have adapted it a little bit. It made some changes to the workflow. So basically, you can just create we have these two bodies, right? So on the lead, I just come to one side and I just need to create a rectangle. This will be a center rectangle. And I'll just give it 2 dimensions. This is also something you need to change sometimes. Like if the fit is really tight or you want it to be tighter, you might need to change that. Like for example, the tab width. I'll give it 5 millimeters. And then tab height, give it 2 millimeters. It's okay. And then I'll just create it here in the center. So this is the tab height. This is the tab, width. Okay. Yeah, I just noticed something that's wrong here. If I want my tab to be 2 millimeters, well, let me just go on with it, and I can come back and change it so you can see why I think it's wrong.
Yeah, that'd be good.
Okay, so here back on the sketch, I will create an offset rectangle smaller than the outer one, and I will give it the clearance that we are using for our assembly. Okay. So now what I need to do is I will extrude the larger one. I can extrude the larger one by any distance. I can give it, I don't know, 5 millimeters and minus 45 degrees. And I will select a new body. Okay, so it doesn't join. Okay, so then I hide this body, come back to the sketch. I can call it tab sketch for later. Okay, I bring up this sketch again. I do a new extrusion, again, random distance, doesn't really matter. Minus 45 degrees, and this time I join it. Okay, so now it's part of this component here. I also like to add some fillet. Like here, I will add a 0.5 millimeters fillet. This is also something will be good to make a parameter. I will just leave it 0.5 in this case. And actually, I like to add the same fillet to the other body as well. I do that. Select the other body, 0.5. Oh, sorry, lost the clearance. Okay. So yeah, we have this body here, now it's like a tool we can use to cut on this frame component. So we can just go and do modify, combine. I will select the target body, will be the case, and the tool body will be this body tree. I didn't give it a name. I don't keep the tool. You could, if you wanted, keep the tool, but I don't do that because I'm not going to need it anymore. So yeah, when you remove the lid, if you hide the lid, you can see, and I'll hide the sketch, you just created this casing here. Now, the reason why I said it's not okay, it's not correct, something was not correct, is because if I 3D print this, the distance here, it's really small, like you have 0.15 millimeters. So that's about 1 layer line. So this is likely going to split or tear apart when you, either when you insert the lid or when you remove it. So my mistake was when I created the lid component, I extruded it by 2 millimeters. I think I needed to do a longer distance. So the way to fix that, if I select it here, I can see which feature it references to. So I hit right click, edit feature. Instead of -2 millimeters, I will do -3. I could do -3.5 also if I wanted. Let's do -3.5. Okay, so now it's thicker. If I do the section, it's thicker. And because I created this this sketch using the middle points of this line that I made, it automatically shifts the rectangle, so it adjusts the position. And now you see, let me remove the section and hide the lid. You see here you have more distance here. So it's 0.9. So there's a couple layer lines there, a bunch of layer lines if you're printing at 0.15. So it's more resistant. It won't tear apart as easily as it will before. The other thing is, because I was using the combine operation downstream of the extrusion of the lid, let's see the section again. You see now the cavity is now larger. It adjusted itself directly because this combine feature is downstream of the extrusion. So when I change the extrusion, it just adjusts here. So that makes it easier. Something I like to do now to propagate those tabs. I like to do some pattern. I will do a circular pattern. And now it's counterintuitive because we are working on a square, but we have an axis. Since all the sides of the square are the same length, we can just reference the features that we just made. So we can just select both extrusions, even the fillet and the combine operation. Can select this axis. If we can make it 4. We use the adjust compute type and hit OK. Takes a couple seconds, and then when you come back, you now have the 4 cavities. So you now have a function design. Like you could just print this as it is if you wanted. Last touch I want to add is on the lid. Let me hide the AirTag. I will just make an offset here. So I will just add a little bit more clearance here. So minus my clearance parameter. That way, if I bring this all together, when I look at it from the side, on the section view, it means it will have some clearance here. So if the printer is not as accurate, or even just because printers are printers, if you're doing FDM printing, you will have more wiggle room for closing this up when you insert the AirTag. So yeah, this is the finished design. It's an AirTag holder. It's pretty, I think it's a pretty simple design, but making the SnapFit tabs like that and propagating them, I think it's a useful trick to have under, under the sleeve when you're designing enclosures and things like that. It's very, very easy to do. And the good thing is, if you have the parameters here, you can do a test print, for example. Like if you print only some part of the design. This is not the case, but if you had a larger design, if you made something like this on a larger design, you could print a small section and test the fit, and then you come back here and adjust the parameters. You don't have to redo the model or go and edit the features. You can just adjust that directly. Makes it really convenient. So
yeah, and I think that is a really good example. Even the mistake you made, I guess, if you want to call it that, I think it really demonstrates how having a well designed and thought out CAD model, you can fix things like that pretty quickly, and then everything updated the way it was supposed to, so that you didn't have to go and make a lot of changes, which is the kind of the benefit of parametric design software. And having the merge, or the cut command, merge body with the cut in the right place, it automatically updated the top cutout like you demonstrated. So I think that is a really good showcase of what like a good parametric design looks like, as far as not having to go back. Because I think a lot of people would be tempted to make a manual extrusion there, where you might when you had the 2 millimeter thick top, you would extrude some distance to make the clearance work, and then when you change that, the top thickness, then you'd have to remember, I have to go and change that as well, which is really easy to forget, especially in longer, more complicated models. So having things that reference each other like you did, I think is a really good principle to practice and understand. So I think it's really good.
Yeah, thanks. Thank you. Yeah, I really like using the change parameters features. It really helps you harness the true power of parametric design. But even if you're not using parameters, just having features reference geometry, or like you said, other features, helps you down the road when you need to make changes. So, but it's something of course, you need to get used to it, like trusting the fact that it will update when you change it, because you are giving it as a reference, a face or a plane, or maybe trusting the sketch constraints, like you added this constraint there, so it will remain like that. You need to go down the line and make a manual extrusion because you added that constraint, so it will update accordingly. But of course, it comes with practice. Sometimes also when I'm doing designs and I'm doing something really quickly, I would go, like, if I didn't add the parameters, I didn't add the references like that, I will go manually and start, like adding extrusions on top of extrusions, or adding the press and pull parameters to, adjust things. We all do that, I think.
I definitely do that.
It's okay. It's perfectly fine. I just find that when I have the chance to, okay, let me sit here and think how I want this to work down the line, it helps me get a more organized workspace and feature tree and so on. Like this case, we have few sketches, and yeah, I think it's very organized. But I think the first time I did it, or the first time I did something like this, it was, of course, it was not like that.
Right.
It was more back and forth, you know, like different extrusions here and there. And then I figured out, okay, I could just have done a shell command instead of extrusion plus another. So yeah, I think comes with practice. The more you use it.
Yeah, and I think that that's a good thing to get in the habit of if you have the time. I mean, I've kind of mentioned this on my personal social media, but I don't really sketch designs very much. Like I know some people, sketch stuff out on paper first, but a lot of times if I think about something, I'd do a very rough CAD model where it's like basically a disaster as far as like textbook, how you're supposed to do it versus what my timeline looks like, and then you can try to see if something would work or an idea in your head would actually work in real life, and then you can always come back and remake the model. And I mean, usually when I have it pretty close to what I want, I mean, it's a lot easier to remake it. You would think it would take a lot longer than it actually does when you have the measurements pretty much honed in from the rough model to make a more polished one. But I think that's a good thing to kind of get in the practice of, is just practicing, how can you make this more simplified and more kind of structurally sound model. So yeah, I think that's a common thing that people do.
Yeah, definitely. Even myself, like sometimes I'm mindful or hesitant to share Fusion 360 model. Like we share STL files all the time with TwoThingies. Sometimes I don't want to share the Fusion file because I'm a little bit let me say ashamed of how the feature tree looks. And I think, okay, if someone else has to work on this design and adapt it, no one will understand what it's what it's supposed to do. So just having organized feature trees like this really helps you, even when sharing your work with others, or even for yourself down the road. If you open on a design that you did a couple of months ago, and then you don't remember all the operation that you did, it's easier to have an organized tree.
Right, for sure. All right. Well, I have a couple quick questions kind of at the end I like to do with everyone that I talk with. So what's something you wish you learned sooner about Fusion?
Okay, this is something I learned just a couple of days ago. If you left click on any feature, for example, if you want to select something behind this body, I will just go and hide the case and then go and select the feature I'm looking for, right? So, but actually, I just learned that you can hold the left click and it lets you toggle through different things that are behind what you're seeing. So that's really helpful. That's something I didn't know about it. I learned about it this week. So I think I will be using it more often.
Yeah, that's a really helpful tip. I call it like the X-ray vision mode or something, because that's kind of what it does. It sees through whatever your cursor's pointed at. So yeah, and it can be really helpful when there's something that's for whatever reason hard to select. It really makes it possible to do that. So cool. Yeah, I like that you shared that. So another question is, how did you learn Fusion? Did you take any courses? Did you just learn through YouTube? Was there any individual channel or person that you felt like helped you get a lot better at it, or was it just like kind of trial and error? What are your thoughts on that?
Yeah, I learned from YouTube videos. I learned from a lot of tutorials. I learned, especially there's this guy on YouTube, Product Design Online. If you're familiar with him,
oh
he
yeah,
makes
yeah, he's
some
really
really good videos, and also I think some people around the 3D printing community, like for example, Maker's Muse. You know,
Right.
Maker's Muse.
Yeah. Yeah.
He made some tutorials, not in-depth tutorials. I think more like how he did some features on Fusion. So looking at how other people do things on Clock Sprint 3D, for example, like when I had this feature I just showed you, he showed it in a video. So yeah, I find that looking at other people, how they do things really helped me. So I think there's a way to pay back. Like hopefully this could be useful for someone just learning.
Right. Yeah, that's the same thing here. As I just watched a bunch of YouTube videos, and I think too, it's now more easier than ever to, if you're trying to make something in particular, you can search for some solution for that particular problem that you're running into, and kind of see how other people have accomplished it, and learn from that. I think just trying to make stuff and then figuring out ways to do it, I think is a really good way to learn. So yeah, I think that's a pretty common thread is YouTube, and just kind of doing stuff and figuring out along the way. So the next question is, where do you get your design ideas from? Like, do you have anywhere that you get inspiration? Is it just brainstorming, or are you just trying to solve problems? How do you go about getting your designs for your 3D prints?
Mostly it's just solving problems or things we have. Like you have the what wife wants, we have something similar.
Yeah.
Like TwoThingies actually started a little bit like that. Like when I got the 3D printer, we I would always design things because I like it. But sometimes we will need something around the house, and I will push to okay, let's not buy it, let's try to print it. Let's try to make a 3D design that can solve that problem. I know we have a store down the road. It's, for 60 cents, you can buy something similar to this. But I want something very specific. I want to be able to do it with 3D printing, and maybe it becomes something useful for other people. So that's how it started. That's how I get most of my ideas, and with Uri, sometimes we're walking down the street, we see something and we say, okay, that's something you could easily 3D print, and then we start brainstorming around that, like how to do it. Other inspiration comes from woodworking and design product design, renders. I like to see a lot of product design, the work of different product designers and design studios. I think they use some features and shapes and forms and methods that you don't see like in your daily life. So it's a good source of inspiration.
Yeah, I've thought that woodworking in particular, I think it's been a big draw. And even just like I made one short at one point about just AI generated stuff. You can some of it's very out there with, if you ask Dolly or something like that to make something, but sometimes it does make things that are doable to some extent. So I think there's a lot of different ways to get inspiration. But yeah, I think that solving problems, even if it is something that you could buy from a store, I think just having the ability to think things through and make something that fits some other product that you have or something around the house, I think that's a good technique to learn. And at some point there might be something you think of that's hasn't been done before, and you'll kind of have built the skill set to maybe accomplish that. So I like that kind of idea of just trying to solve different problems, even if it is something that could technically be bought. But I think that it's just a good thing to do. It's just to build up your skills in Fusion, and it's a enjoyable thing to. I feel like it's a pretty good feeling when you think of something and kind of go through the process and probably mess it up a couple of times and finally get it to work. So you get a sense of fulfillment out of that, or at least I do. So I think that's something that's fun about it for sure.
Definitely, it's you feel it's a great feeling, like, oh, it works.
Yeah. Your eureka moment. So finally got it. Cool.
Exactly.
And then I feel like I know the answer to this. But do you use a mouse or a trackpad?
No, I just use a mouse. Just
Yeah.
use a mouse. Just cheap mouse. That's from
Yeah.
Amazon.
Right. Yeah. It doesn't have to
Nothing
be
special.
it doesn't have to be a fancy one, but I think using a mouse in general is makes your life in Fusion a lot better. So if
Yeah.
anyone's listening, it's time to invest in a cheap mouse at least. So
Yeah.
it's a good, very worthwhile investment for sure.
Yeah.
And then the last question I have for you is what is your favorite design that you've made, or what is your design that you're most proud of? So, it can be the one you've sold the most of, the one that was the hardest that you figured out a solution for, or just whatever kind of comes to mind there.
Well, actually, it's one of the first designs we shared as TwoThingies. It was, well, we started TwoThingies, and we wanted to, share photos and videos of what we were doing with 3D printing. And at some point to record the videos, I figured, okay, it would be easier if we had some support to hold the cell phone on a tripod.
Mm-hmm.
And being a maker, instead of buying it, I designed it. So I made this one. This is the one I've made that time, like in 2022 or 2021, I think. This is the one I printed. It's the only one I've printed. So I'm really proud of this design because it worked the first time. Like I sat there and I tried to really plan how it works. And I think it has a bunch of features, like it's self-centering, it rotates so you can adjust the position of the cell phone, but it's really thought for printing. Like I put a lot of thought into it before actually printing it, and it works the first time. And then a bunch of people have downloaded it, and they have shared their feedback, and it works also for them. So it's a really nice feeling, like, oh, it worked.
Yeah.
So yeah.
Awesome.
You can see it's a little bit worn out after the years I've been using it, but yeah, it works.
Yeah, it did its job, and I think that's really cool that it's something that I think I like that question because I mean it may or may not be the most downloaded or most popular design, but sometimes it's the self-fulfilling aspect of like you said, kind of thinking it through and it worked the first time. I think that's sometimes what makes us, I guess, feel the most fulfilled about different designs. So really cool. Thank you for sharing that.
Yeah, sure. Yeah.
All right. Well, Louis, where I guess tell the people where you'd like to connect with them, whoever's watching. And do you like people to follow you on Instagram, or what's the best way to keep up with you?
Well, we post not so regularly, but we do post on Instagram and more recently on TikTok as TwoThingies. We try to share also, like, as we are doing things, what we're doing. And our designs are available. Most of them are for free on printables called 3D. We also started sharing on Thangs 3D.
Yeah.
So anyone who would like to see what we're doing or get in touch, we are on those platforms.
Okay, awesome. Well, thank you again so much for sharing your design with us and your time. And I think that a lot of people get a lot of good useful tips out of this. And I know that I learned a lot of different things as well. So thanks again, and really appreciate it.
Yeah, thank you for having me. It was really nice to be here today with you.
Awesome. Well, thank you, and thanks for everyone watching. See you in the next one.